Welcome to the Master the NEC podcast, the ultimate destination for anyone passionate about the electrical trade. Whether you're a seasoned electrician, an eager apprentice, or just someone who wants to dive deep into the world of electrical work, you've come to the right place. Join your host, Paul Abernathy, a true authority in the industry with over 38 years of trade experience, as he electrifies your mind with in-depth discussions, expert tips, and valuable insights that will keep you ahead of the curve. Each episode, Paul will illuminate the complexities of the trade, decode the National Electrical Code, and share the latest industry trends, all while empowering you to take your electrical career to the next level. So, gear up, plug in, and get ready to supercharge your knowledge, because with the Master the NEC podcast, the power is in your hands. Now get ready. Here is your host, Paul Abernathy.
Yo! What up, everybody? Paul Abernathy here. Thanks for joining me on today's podcast here at Master the NEC Podcast, where we talk about the National Electrical Code and, of course, all things electrically related. Glad you could take time out of your day to join me for this podcast episode. It's been a minute since we've talked the National Electrical Code. I've been very busy working on the Stack Caddy project, which is a separate website, folks. If you get a chance, go look at it, stackcaddy.com. Some great products over there to make your life as an electrician just a little bit easier. Plus some cool stuff as well, like a wire nut koozie and all kinds of good stuff. So check that out. We constantly have new things coming, but we have some neat ladder trays and step caddies and just some neat stuff. And if you're an electrical inspector, we have a neat little inspector caddy over there as well. So check that out over on stackcaddy.com. But we've been busy working on that and trying to get the 2026 edition going. But including that, I've also been busy working on some articles for ECNM magazine, as you may have heard. I am going to be writing for them. I'm one of their NEC experts. And I'm going to be writing some articles, I think 6 of them, that we're going to be doing for the next year, every other month. And I'm going to be focusing on inspector-electrician relationships and different things where they get in disputes and interpretation and all those kind of things. But I'll also be doing some videos explaining some code things for them, as well as some podcasts also. So check that out with ECNM magazine. So I've been busy with that. And I've also been extremely busy with thermal electrician, as well as the CMECP program, and just so much stuff going on here at the Academy that it's kind of caused me to not be able to do any videos in a while. And I have not been able to do any podcasts really in a while. So, bear with me. This will all cycle back around and we'll get back to the normal schedule where I'm posting all kinds of content, especially with the 2026 edition of the NEC, soon to be adopted by a couple states. I think in September, Texas will pick it up, and Massachusetts maybe soon, or they may be in the amendment stage to it. You know how they got to change some things. But anyway, all that's around the pike, and we're working on our 2026 program for the fast tracks, in case you haven't heard. And it's taking a little longer than normal because of the illustrations and graphics. It's just a lot of work, and I don't have the same amount of time as I used to, so I'm trying to get that out as quick as I can. The good news is most of the stuff that we're doing, you're still a good year out, maybe 8 months out, where your state is still going to be on the 2023 or 2020. So we've got plenty of products for that. So check it out. And if you're interested in learning the NEC. But of course, thank you for joining us here on this podcast, where today we're going to talk a little bit about the 2026 edition of the NEC. We're going to talk about a significant clarification. And I think it's the way it was supposed to be, but everybody, even including me at times, can get confused with it when it comes to that 25% for the largest motor in a calculation, as well as understanding non-coincident loads and how they would work together. And we kind of straightened that out in the 2023 edition. I think everybody was pretty clear on how you would do that. But they've made it, the code panel made it so much easier to understand in the 2026. And of course, now everything makes better sense, right? So we're going to try to make sure that we clear that up and we're all done with that. And now everybody can move forward when it comes to non-coincident loads and that infamous additional 25%, which, by the way, you're not going to see it say that in the code. You just have to understand that when you have multiple motors or motors and other loads, that you're going to take the motor at 125% plus a sum of the other loads. And based on the language of the code, if you have multiple motors in 430.24, which you will if you have a bunch of appliances that are in a building or in a dwelling, you're going to take the largest one at 125% and the sum of the other, which are probably already going to be accounted for when you do the appliance calculation. So anyway, we'll talk about all that. That's what we're going to be covering on today's podcast. So buckle up and make sure you got your code book. Again, feel free to pause the podcast. Remember now, we have over 1,000 episodes available on all your popular platforms. Just go searching for Master the NEC Podcast, and you'll find our podcast. I'm a podcaster. I love to podcast way more than I love to do videos. I like the challenge of being able to convey a message in audible form rather than just having an image or an illustration. I think that sometimes you can tell whether or not somebody really has a grasp of the topic by how they can explain it. And that's what I like to do. I like to do that. But at any rate, let's go and get into today's topic. So first things first, you all know that in the 2026 edition of the National Electrical Code, that the calculations that were previously in the 2023 were Article 220. And in the 2026 edition of the NEC, that got moved over, and it's now Article 120. So again, not a whole lot of technical changes. You still got Part 3, which we call the standard method. You still got Part 4, which is the optional method. Still have Part 5. And you still have all of the same technical information. It's just been moved into Chapter 1. And you're going to see a lot more of this because we've already started working on the 2029 edition of the NEC. And I know there's people out there that say, don't change it. But the effort is to try to make things a little easier to flow. We can't make it any easier to understand. We try. Every cycle, we try to make things easier to understand. But the real issue is to try to make it flow a little better. Keep the calculations up front where they need to be, and just kind of let things flow a little bit. So the 2026 edition, we're starting to dip our toe in moving around significant articles. And so that was what we did with Article 220, got moved to 120. So people ask me all the time, can I take an exam? It's on the 2026. Can I use a 2023 code book? Absolutely. The technical information to be the same. You just need to be aware that the code sections may change a little bit, right? Article may jump around a little bit, but as long as you've prepared for that, you'll be okay. You just have to know how to utilize the NEC and how to be able to jump back and forth and use the table of contents, use the index, those type of things. And then understand some things will change. And in some states you can write in your code book, so you can make a little note in your code book or something like that. But again, only do that in the state that allows you to mark in your code book. Now, if you're already licensed and you just got your code book in your truck, then you can mark all you want in your code book. It's your code book. You own it, and you can mark whatever you want. All right, so let's get started first. So what we want to do is let's look at the scope really quickly of 120 so that we know what we're dealing with. And of course, we're going to focus on the non-coincident load aspect and that infamous 25% for the largest motor that people go looking for that language and you don't find it. And they say, well, where's that in there? Well, I'm going to explain to you where that comes from. But we need to look at the scope. Always read the scope, especially if you're digging into the NEC and you're not overly familiar with it. Take time, whatever article you're in, stop and go read the scope and see if exactly what's covered in this scope is what you're needing, that type of thing. So here it is, 120.1, the scope. It says, this article provides requirements for calculating branch circuit, feeder, and service loads. Part 1 provides the general requirements for calculation methods. Okay, so we're going to look at that. Now, obviously, we're in Part 1 for the non-coincident load, gives us the direction here. And then it says Part 2 provides calculating methods for branch circuit loads, which we will use these for our load calculations in Part 3 or Part 4. And then you have Part 3 and Part 4 provide calculation methods for feeders and service loads. Part 5 provides calculation methods for farming loads or farm loads. Part 6 is going to be calculating methods for healthcare facilities. Part 7 is going to be calculation methods for marinas, boatyards, floating buildings. It's typically talking about the receptacle loading, by the way, but it's going to give you that direction there. And then we get into Part 8, which provides calculation methods for recreational vehicle parks. Okay, so that's the scope of 120. It's nothing different than it was when it was 220. Okay, let's get that out of the way. It's just a movement. And you just have to get familiar with the fact that it's moved into Chapter 1 now instead of being in Chapter 2. Okay. All right, let's go on and tackle this issue about non-coincident loads in 120.6 of the NEC. Okay, so here's what it says. Non-coincident loads. It says, for 2 or more non-coincidence loads, it shall be permitted to use the single largest of these loads in the calculation of the total load. Okay, so we're looking at non-coincident loads, and we need to know what those are. And we do have some direction here in 120.6. It's going to give us some clarity to that, which is great. But once we determine which of the loads that are considered non-coincident loads, then we'll take the larger of the 2 or 3 or 4 or whatnot. Okay, so we'll kind of see how that would play out. Now, again, as educators, we tend to want to use AC versus heat as the primary example all the time that you would see in a dwelling application, because, I mean, that's just the easiest way to try to do a comparison, right? Because typically the heat wouldn't be on at the same time as the air conditioning. Of course, it's a heat pump, then it may be, which means that isn't a non-coincident load. But that's the concept, and that's why we usually will compare a heating load versus an air conditioning load, right? And for most electrical exams, they're just going to give you the AC load and then give you the heating loads, and you have to understand how to compare them and how to do this type of thing. But we're going to kind of break it down a little bit. So that's the first part of it. I can take the largest of the non-coincidence loads and just go with the largest value, okay? And then you just totally discount the lesser value when it comes to the load calculation. For example, if I have a certain amount of load and I have 2 non-coincident situations, pieces of equipment, okay? And so this piece of equipment can't operate while this one's running, this one can't operate while this one's running, this one's pulling 100 amps and this one's pulling 80 amps, and I'm adding this various load to my load calculation, then if I do everything based on the one that's a higher load, then anytime the one that's the lesser is running, but the one that has the greater load isn't running, but I sized everything as far as my load calc to the larger of the 2, then it's okay. It doesn't matter because it's going to be less, and I sized everything based on the larger value. So that's okay. The only problem that ever comes in with that is if by chance I am going to end up running these 2 loads simultaneously, and then of course that would not be a situation where they are now non-coincident loads. So that is absolutely something that the design engineer has to take into consideration, the electrician that's doing it, especially if you want to utilize the rules in 120.6 when it comes to non-coincident loads. So it truly has to be a non-coincident load. So now we understand that. We understand we can take the single larger of the loads that are non-coincident loads. And again, if it's 3 loads and the third one is larger than the other 2, then I size it to the large one, and they're all non-coincident loads, means they're not going to operate simultaneously. Then what happens is I'm okay. I just take the largest value and I can discount the other values in my load calculation. Makes sense? Okay. So now it says, how do I determine these values? So to determine how I do the comparison of these non-coincident loads, it says determination of the largest non-coincident load shall include treatment of any motor-operated and combination loads as specified in 120.11a. So we're going to have to take the time to look at 120.11a because now we have directions on how to determine which load of these non-coincident loads, which one is the largest one. And so we'll get directions for that, okay? Now, the last line here is clarity on what constitutes a non-coincident load. And it says, non-coincident loads shall be considered to be one of the following. Okay, so the first thing says, look, for feeders or services, if you have two or more loads that are unlikely to be in use simultaneously, then there you go. For feeder or service load calculations, if I've got these two or more loads and it's unlikely that they're going to be on simultaneously, okay, then those would be considered a non-coincident load. I say be careful with this because this is a determination it is made based on analysis of the circuits and how they're supposed to run and how they could run, and that would be the engineers would design this out or look at the system. Whereas the next item says, because it's basically any one of the following. So here's a second one that makes it a little easier to understand. The second one says, for branch circuit feeders or services, it says two or more loads that are prevented from being in use simultaneously by listed equipment. So this is where, I talk about the interaction between an electrical inspector and an electrician in understanding whether something is unlikely. So, because, unlikely doesn't mean impossible, right? Whereas if I have some piece of equipment that is listed that makes it impossible, okay, barring some event we can't control, it's impossible because of the equipment's nature and how it's designed, like Kirk keys, where you can have, two different services coming in and one can't come in if the other one is the way the switching is, right? So it's inherent to the equipment, and it's listed equipment that's going to isolate one from the other. Well, that clearly, if I have a piece of listed equipment that's going to say that this load cannot run when this load is running, whether it's some kind of inherently the way the equipment is made, whether it's part of a listed device, whatever it may be, that one's easier to be able to push to the inspector and say, look, reason I'm taking this load and I'm discounting this load is because I have a piece of equipment that's listed that's going to keep this load from being on while this load is on. That makes sense. That makes sense to me. The argument that can creep in is item number one, and that is where you have these two loads or more, and it says that they're unlikely to be used simultaneously. It doesn't say it's impossible. Two people could turn something on. They're just unaware of a sequence, and then they both run at the same time. So that one, obviously, if an inspector or somebody's getting deeper into it, or maybe even a plan reviewer looks at it and says, okay, I understand where it would be unlikely, but you need to show me how it would be unlikely. That's reasonable. I mean, I would, I don't have a problem with that. I mean, if that's the case, and it is, like, this piece of machine would not run because it needs this other machine to run in tandem with it, and it can't run when this one's not run. If there's some kind of means that makes it unlikely, then it's inherent to however it's designed, then that's one thing. But if I also have a piece of listed equipment that's going to prevent it so that it can happen, then that's for me, that's a no-brainer. Then that is clearly a non-coincident load, and I'm going to take whichever one yields the largest load, and I'm going to size my loads to that. That makes sense to me. The only argumentative one could be item number one, but I think today most people will design things out, and the way equipment may be laid out, it may be very obvious that this can't run when this is running or whatnot without any listed equipment. But you get two options here, two paths to be compliant here. And so again, I can't speak for every possible application that could be conceived in this. I'm just saying that the local AHJs, and I talk about this all the time, that we all have to be open-minded about how this may be done in the design and the layout, that either way, that's how you would create a non-coincident load situation. And again, this would allow us to take the larger of those non-coincident loads and treat that load in the calculation rather than the ones that are of the lesser value. because they're not going to be running at the same time that the larger one's going to be running. You get me? Okay. Now, that's pretty straightforward, and that gives us a direction of being able to take the loads and understanding what's a non-coincident load. Now, the problem that we had in the 2023 edition of the NEC was making reference to imply that it's had to do with the justification for 220.60 through the last couple cycles, where references were made to 220.50, which was for motors and things like that. And it really muddied the thing up. Okay. And what I mean by that is if I'm comparing, let's say, AC to heat, and I'm taking the AC and I'm taking the air compressor, which is the largest motor, and at 125%, okay, and I'm taking that because that's what the language said in the 2023, and I'm comparing it to the heat. If the heat was greater than the AC, and I will tell you, vast majority of the time it will be, if there is resistive heating and things like that. Okay, for example's sake, if the heat is the larger of the two, and it is truly non-coincidental with the AC, okay, let's just say that. If it's truly non-coincidental with the AC, means that one can't be on when the other's on, then let's say I get rid of the AC loads because I'm going with the heat because it's a greater value under this non-coincident load application, okay? So the 125%, which is what was directed to us to utilize in 220.60, you don't see that now in 120.6, because what you're going to do is you're going to get that inferred when you go over to 120.11a. And so that means we have to look at 120.11a. Okay? So if we go over and look at 120.11a, it says motor operated and combination loads. Now, this is actually broken down, and I would have loved to see this broken down in a 1, 2, 3, just like we started doing in a lot of other sections, where it's easier to follow, kind of just broken down into an itemized. It just makes it easier to follow. And we didn't, and that's okay because it's still there. It's still all there. It's still broken down into paragraph. But here's what it starts out with. It says, where a circuit supplies only motor-operated loads, the conductor sizing requirements specified in 430.22 shall apply. Now, you think that this only is applying to this conductor sizing here. Well, we're not in 210, so what it's talking about is you're going to use this same scenario in order to do the load calculation. So the same concept. So for a motor-only loads, if all of my loads were the non-coincident loads, if they were all motor loads, then I would simply take the motors at 125% if they're continuous duty motors under 430.22 for a single motor, if that in our example, and whichever one is the larger, that's the one I go with. And then I discount the others. Because again, if that motor, the larger motor's running, then, and the others are not, because they're all truly non-coincident loads, then there's no harm, no foul if everything is sized based on the largest load. There's no harm, no foul. But that is driven by the fact that all of these we're talking about are motors. And in a commercial industrial facility, they may be the case. So you may have non-coincident loads, but they just happen to be, motor loads. And this is how you would utilize it. But to determine the larger of those non-coincident motor-only loads, you would use 430.22 for that, okay, for that application. Now, if it's the circuit is supplying only motor-operated loads, okay? Now, it goes on to say, all right, well, the second part says where the circuit supplies only air conditioning equipment, refrigeration equipment, or both, the requirements of 440.6 shall apply. So when it comes to the air conditioning and refrigeration, you're going to be up in Article 440, and you're going to be at .6, which is basically to pull things from nameplate values, okay? And so the rated load current, you're going to get all of those information from there, and you're going to use that and you're going to compare. Okay. You're going to compare with your other non-coincident loads. Okay. That's where you're going to get that direction. Now, it says for circuits supplying loads consisting of motor operated utilization equipment that is fastened in place and has a motor larger than 1/8 horsepower in combination with other loads. And I will remind you that in an HVAC system, the air conditioning compressor is probably going to be larger than 1/8 horsepower, and that is going to be a piece of fastened in place motor operated utilization equipment under these conditions. Okay. So it says if that's the case, then the fastened in place with the motor larger than 1/8 horsepower in combination with the other loads, maybe a condenser fan, maybe a heat pump or whatever. Okay. To calculate shall be not less than 125% of the largest motor load, which would be that air compressor. Compressor, yeah. And then plus the sum of the other loads associated in accordance with 430.24. So in terms of the motor aspect of it, okay, 125% plus the sum of their loads, okay, and compare that way. That's how you would tell. So if you're utilizing that and you have a fastened in place motor operated utilization equipment and the motor is larger than 1/8 horsepower and you have other loads as well, then you take that load at 125% and the sum of the other loads together, right? And that may be your largest load. And that's what you would use in your comparison of these non-coincident loads. You with me? So this is giving you 3 ways to determine the loading. And so I think I can break it down into maybe even more of an, kind of a step-by-step process, right? So if we're thinking about this, and we haven't even talked about 120.50 yet when it comes to motors, because that 25% that everybody's thinking, if I'm using the motor and I'm doing it at 125%, it's the largest motor, and then the sum of the other loads, then that 25% that may be covered by reference in 120.50 may already be covered. But if I'm doing a heat versus AC, for example, and the heat is still larger than the AC, even if we did the AC at 125% plus the sum of the other loads, if the heat is still larger, then that AC value is gone. Therefore, that motor is gone. So then and only then in 120.50 will I have to hunt for the next largest motor to comply with 120.50 because the AC now is not in play anymore. Because in the scheme of the loads, the heat was larger, so that's what got utilized. Again, that's the cleanest example that we use for dwellings. It's just simple, AC and heat, right? So let me give you an example. I'll try to give an example of maybe how this may work. So let's see here. So let's say we have a calculated air conditioning combined load of 7,500 VA. And we have an electric heating load of 10,000 VA. Well, obviously, if these are truly non-coincident loads, then the larger of the two is the heat at 10,000. So that means that the AC load is omitted under this portion of the calculation, right? Because if it is truly a non-coincident load, then we went with the larger of the two. So it makes sense, right? Because as far as load calculations go, hell, if I size everything for the 10,000 VA, what do we care if that's not running, but the 7,500 air conditioning is running? Because it's less than 10, who cares? Now, granted, you're going to size everything to the air conditioning separate, just like, the conductor sizing. You're going to do that separate. We're talking load calculation right now. Okay, overall load calc. Okay, not your branch circuit calculation, not your conductor sizing, not your overcurrent device. That's different. We're talking in a load calc here. Okay, so the heat is larger, so you omit the AC. So the compressor is no longer part of the feeder or service load calculation. It's just been removed from the equation. Now, that does not remove us as we move further into the load calculation when it comes to 120.50. Because 120.50 is dealing with motors, right? Or HVAC or air conditioning, right? So we have to still deal with that. So now, under the 2026 NEC 120.50A and the reference motor rules in 430.24, 430.25, 430.26 for the motors, that remains part of a calculation. That's not gone yet. Okay? So if I've omitted the AC compressor as part of the AC versus the heat in a situation where they are truly non-coincident loads, again, we're not talking a heat pump, because that wouldn't be a non-coincident load. There's a different calc for that. Take nameplate values for that. Okay? We're talking where you may have a true non-coincident load. Means that thermostatically, the AC can't come on when the heat, if that's the case. Or you could have baseboard heating. And if you have baseboard heating and you're going to be taking that, then you're going to be taking that baseboard heating at 100% of its value, right? So at the end of the day, we have to understand that the differences in the two and how we would calculate that. Because under the heating, if it's fixed electric space heating, then that would be 120.51, and that is basically at 100% of the total connected load. Okay? All right. So we just need to understand that we all use the AC versus heat as an example when we're teaching this stuff. But remember, this could be any situation where you have two separate loads that can be classified as non-coincidental loads because they're not going to be simultaneously used at the same time for your calculation. But that does not remove our situation in 120.50. Okay? Now, let's assume that in our situation, the heat was greater than the AC, so we omitted all the AC. Let's assume that those were non-coincident loads for argumentative sake. So therefore, since we've omitted the AC, when we get to 120.50, now we still have to find the largest remaining motor. And let's assume we have a well pump at 1920 VA. Let's assume we have a blower that blows the heating around at 600 VA. And let's say we have a garbage disposal at 500 VA. Well, in this scenario, the next largest motor, true motor, would be the well pump, the well pump. And it's at 1920 VA. Well, you do that, multiply that by 25% because we only want to get the 25%. And you say, well, why? Because we're already accounting for the well pump in our normal appliance calculation. We're already accounting for it. So all we're trying to do is grab that additional 25% in order to meet the application. Now you say, well, wait a minute. How does that work? I'm like, because these are multiple motors. So remember what we said in 430.24? It says take the largest motor at 125% and the sum of the other motors. So I've already taken the sum of the other motors. I've already figured in the well pump. I've already figured in the heating blower. I've already figured in the disposer. All of that up when we did the appliance calculations. So there are more than one motor here. So that's why we take the largest motor at 125% and the sum of the other. Well, you've already taken that well pump into the calculation, so we just need to grab that remaining 25%. And I think that's the hardest part for folks to grab because it doesn't say grab that 25%. All we're doing is trying to do what 120.50 is asking us to do. That's it. That's all we're trying to do. So it's a mental gymnastics that you have to do and understand that. So for example, that 1920 VA for that well pump, that would give us an additional 480 VA to add to the equation, right? So you're going to have 100% all the other motors in there. And then you're going to have 480 VA for that additional 25% of that largest motor. Makes sense? Now remember that's okay that you could have other allowances in there for multiple appliances. Okay, 4 or more, you get a reduction. That's fine. That's allowed as well. Okay, so don't confuse the two. That's just a totally different step. And again, we're talking standard method part 3 right now, okay? Because that's typically where people get confused on this. Heat versus AC is a totally different process in the optional method chain, okay? All right. So under the 2026, one of the things that was important is that the distinction needs to be made that the AC compressor's 125% treatment under 120.11a is used when determining whether the cooling or the heating is the largest non-coincident load. And once the heating wins this battle, let's say, then the AC is omitted. That is where 120.50 is then applied to the motors that are remaining in play. You get what I'm saying? Those that are remaining in play now get this. So the rule is, and if I had to do it step by step for you, I would say first, calculate the AC properly under 120.11a. Next, I would compare the AC with the heat, utilizing the 120.6, and in other words, taking the larger of the two. Next, I would say retain only the largest of those two loads. And then the last step, apply 120.50 to the motor remaining in the structure that is now the next largest motor, because probably the air conditioning compressor was the largest motor, but since that was removed because of the comparison of those non-coincident loads, you got to go hunting for the next largest one. Okay, so yes, the next largest motor is going to receive that additional 25%. It's getting it through 120.50 after the larger non-coincident load has been already established, okay? So hopefully that makes more sense on how that's, kind of flows, right? So just remember, when the heat wins, the AC compressor is omitted. You still got to get that additional 25% in order to comply with 120.50 because it tells you if you got multiple motors. And that's what 430.24 says. If you have multiple motors, take the largest one at 125% and the rest at their value sum. Well, again, you've already taken those motors into probably your appliance calculation. So all you got to do is try to capture that largest motor's additional 25% that's missing in order to comply with the 120.50 rule. It's not brain surgery. But everybody wants to find that miraculous words that say take the additional 25%. It's there. It's that you have to read between the lines in 120.50 in order to get there. Okay. Now, this was literally the same concept in the 2023. It was just confusing for folks the way it was written. Lastly, I will remind you, if again I didn't make this clear, in the 2026 edition of the National Electrical Code, Article 220 is moving to 120. Technically, all the same information's there, but this is a great example in 120.6 where it's now been broken up so that you can have the clear direction on what a non-coincident load is, and then it directs you to how to calculate it. Now, for me, I would have liked to see 120.11a broken down into items. The first one with the motor only, second one with the AC, okay, or hermetic refrigerant motor type of thing that's dealing with 440, and then C. It would have been nice to have it broken down like that, but you know what? I can't blame anybody but myself because I did not submit it that way. It's kind of fairly new for us in the code to start breaking things out in itemized format. Usually a bunch of people submit these things and it usually gets broken out, but this one didn't. And I don't know that it's necessary because the periods end each sentence make it very clear how this is stacking the structure. But at the end of the day, I'm sure that somebody will complain about that structure, and then they'll have to break it down even more. But that's hopefully that explains it to everybody. I would not make this more difficult than it really needs to be moving forward. Take your heat. If you're talking heat versus AC, take your heat at 100% plus any of the other associated loads, right? Turn around and then take your AC. If the air compressor is the largest motor, then take it at 125% plus the sum of all the other loads that are associated with it, maybe a heat pump. Not a heat pump, excuse me, a air handler, condenser fan, whatever, and then compare that to the heat if these are truly non-coincident loads. Now, here's the interesting thing. What if the AC is greater than the heat? Depending on where you're at in the country and whether or not you have heat strips or not, if you're in a warmer climate like Florida or somewhere like that, then you'd go with the AC. Well, if you did the AC loads at 125% for the air compressor, then guess what? You do not have to go searching for the next largest motor in 120.50 because you've already accomplished that by taking it at 125%, and it won. It was larger than the heat. So not only do you take that value for the non-coincident load value, but you also are using that value. You've already accounted for that additional 25% under 120.50 as well. Okay, so you're good to go. All right, so that's just kind of one of those things that it depends on, what situation you're in, which wins, and those type of things. So hopefully that clears it up a little bit for you. Of course, if you have any questions, as always, you can leave comments. You can send us an email. You can go to Let's Ask Paul, which is available still. You can go through our website, fasttracksystem.com, and you'll see in the navigation under Info tab, you'll see where it says Let's Ask Paul. Click on it. Doesn't cost you anything. Just fill in the information and send it to us. If it's about a podcast, and maybe give the episode or give a brief summary of what your question's about, and I'll be glad to answer it. Don't make me do a whole lot of work going back because I do so many that it's really, I can't even remember what's in half the episodes I do. So, kind of feed me a little bit of your question, and I'm more than happy to answer it for you. If I confused you, I apologize. I do the best I can. But that's how I understand it. That's how I interpret it. And you may interpret it differently. But that's it, folks. Until next time, stay safe. God bless, and we'll catch you on another episode of Mastering the NEC. Till then, be safe.
Thanks for tuning into another electrifying episode of the Master the NEC podcast. We hope you're feeling more powered up and ready to tackle the electrical world with the knowledge and confidence you need to succeed. Remember, in the electrical trade, knowledge is power, and we're here to make sure you stay plugged into the latest insights, tips, and code updates. If you enjoyed today's episode, don't forget to subscribe, leave us a review, and share the podcast with your fellow electricians and industry pros. Until next time, keep your tools sharp, your circuits clear, and your mind focused, because here at the Master the NEC podcast, we're all about sparking your success. Stay safe, stay smart, and keep mastering the trade. From all of us here at Electrical Code Academy, thank you for all your support, and we will see you on the next amazing Master the NEC podcast episode.